What is motion? Think back to the train at the beginning of the lesson. If the train is moving from north to south, do you have a complete understanding of the train's motion? If the train is traveling south for 460 kilometers, now do you have a complete understanding of the train's motion? The answer to both questions is no. There are additional factors to consider. Let's find out what they are. Lab. Watch it go. This is a design your own lab where you can use a variety of different materials. I have a few shown in this picture. You'll see a tape measure. You could also use a meter stick. I have a tennis ball, some tape, a stopwatch, or any kind of clock with a second hand, some paper towel tubes, a large rubber band, or wind-up toys. You might also choose to use other materials. For the procedure, Step 2. Write a procedure that you will use to measure and describe an object's motion. You may or may not use all of the materials shown in this picture. You might also choose some additional ones. Include in your procedure Part A, the materials you will use, Part B, the method you will use to make the object move, Part C, how you will keep the object moving in a straight line, Step D, how you will measure the distance and time, including the units you will use, Step E, the type of data table you will use to record your data, and Step F, the number of trials you will complete. To assist you in gathering some data, we will be using the tennis ball, the tubes, the measuring tape, the stopwatch, the tape, the tennis ball, and the rubber band. In Step 3, your choice of materials or experiment may be different than ours. Follow your approved procedures to complete your investigation. Record your observations and data on your data sheet. For this experiment, we will be using a wind-up toy, the tubes taped together to make a straight path for the wind-up toy to travel, and we've taken the centimeter side of the measuring tape and attached it to one of the tubes so that we can measure the distance. We will be using a stopwatch to measure how long it takes the wind-up toy to travel. Go ahead and wind the toy up twice. We'll start it at the very beginning, and we'll start the clock on your mark, get set, and go. The toy traveled about 10 centimeters in 6.87 seconds. That was trial 1. Let's reset for trial 2. Go ahead and wind twice. On your mark, get set, go. This time, the elephant wind-up toy traveled about 11 centimeters in 8.1 seconds. Let's do trial 3. We'll wind twice. And on your mark, get set, and go. And this time we are at about 13 centimeters in 9.41 seconds. Record all of the data in your data table. For our experiment, we have chosen to tape the tubes together to create a path for the tennis ball to travel in a straight line, and we have taken the measuring tape with the centimeter side and attached it to the tube so that we can measure the distance traveled. We have chosen to start the tennis ball moving by just a light flick with a finger, and we will be measuring the distance traveled using the measuring tape. Here is trial number 1. On your mark, get set, go. The ball traveled about 30 centimeters in 2.31 seconds. Let's do trial number 2. On your mark, get set, go. This time, the ball traveled about 21.5 centimeters in 2.29 seconds. Let's do our third trial. On your mark, get set, go. This time, the ball traveled about 39 centimeters in 2.41 seconds.